Sammy invests £6,000. The value of his investment decreases exponentially by 4% each year. We need to work out the value of his investment after 2 years. Okay, so we'll just do the part A first, and all that we need to do is write 6,000 times 0.96 to the power 2, or square of 0.96, because it is 2 years, and because it's exponential growth and it is decreasing by 4%, so it would be 96% is what the value of the investment would be. 96% of 6,000, but that would be in the first year. So if it is in year 2, you'd have to raise it to the power of 2. So that's part A, and similarly for part, and the answer I get is 5529.6. Now for part B, similarly, what you do is 6,000 times 0.96 to the power k, is after k years. So for the C part, now Teresa is another person investing 3,000 at the same time as Sammy invests his money, and the value of Teresa's investment increases. So there's an increase here, there was a decrease there, so exponentially by 4%. And now we need to write down the value of Teresa's investment after k years. So that would be 3,000 times 1.04, because it is increasing by 4%. So 104 divided by 100, that's 1.04 to the power k. So that's the answer. And then what they're saying is, after n years, the value of Sammy's investment is equal to the value of Teresa's investment, and we need to show this 13 out of 12 to the power n equals 2. So all we have to do is to equate, 6,000 times 0.96 to the power n here. We don't write k anymore, because after n years the value is equal. And again 3,000 times 1.04 to the power n. So you simplify it, and 3,000, this goes 2, so that's 2 equals 1.04 divided by 0.96 to the power n. And then removing the decimals, you will get 104 divided by 96 to the power n, and 104 and 96, you divide both of them by 8, and you said 8 times 13 is 104, 8 times 12 is 96, so you get 13 out of 12 to the power n is 2, which is what they have asked for. So that's done. Then for the part E, find the number of complete years it takes for the value of Teresa's investment first to be greater than the value of Sammy's investment. So we need to work from what we've just proved, 13 out of 12 to the power n equals 2, and we need to find what n is. So we take the logarithm of both sides, and we get n log 13 divided by 12 equals log 2. And 13 divided by 12 you can write as log 13 minus log 12 equals log 2. We get n equals, using of course using your calculators, it's a calculator paper, so you would get n is 8.66. so it is 8.6. That's when the value is equal, but they're asking us complete number of years it takes for the value to be greater than the value of Sammy's investment. So it would definitely be n equals 9. So in the 9th year it will increase, so we get n equals 9. There's another question here that is a graph. So the sketch graph shows how Teresa's investment changes with time, and on the same graph we need to show how Sammy's investment would change. So we put 6,000 somewhere there, and it would be a decrease with respect to time. So that's, I think, what it would look like, and that is the answer.